So let's talk about piecewise functions. So piecewise functions are basically a new way to combine multiple functions together to get a new one. You should think of it like we have our function machine here, and there's sort of some extra pieces going on the inside. We still have our inputs going in this way, and then we have outputs going out over here. Our inputs are going to be our x's and our outputs are going to be our y's. The function is still going to have a name. Usually these names are f, sometimes you'll see g or h, and of all kinds of other letters. These are the most common. And for piecewise functions, there's sort of two components to it. The first component is a sorting machine. And we sort it into a few different potential boxes. And from there, we go into these mini function machines. Each of the potential bins that we get sorted into has its own machine to it. So it'll get sorted into here, into here, into here. And then depending on which machine it gets sorted into, it runs through that and then into our output. So for example, let me grab a different color. Suppose I sort it into boxes depending on whether x is bigger than 2, or maybe x is less than or equal to 2 but bigger than 0, and then whether x is bigger than or equal, oops, that's not what I want, x to be less than or equal to 0. So these are all of my options. It's either bigger than 2, or it's less than or equal to 2, but bigger than 0, or it's less than or equal to 0. And so each of these boxes gets its own function machine. So let's say the first one is x squared plus 2, and maybe the second one is just the constant function 3, and maybe let's make the last one a linear function of x minus 1. So let's say that's my function f. If I wanted to figure out f of 1, then what I would do is I would take the number 1 and I plug it into my sorting machine. So let's maybe do that in orange. So 1 is my input. So I take 1 and I track it. I say, okay, 1 goes into the sorting machine. Which of these bins does 1 fall into? Well, 1 is between 0 and 2. So 1 falls into that bin, which means it goes into this machine on the inside. And so that tells us that we're going through the constant function 3. And so when it comes out the other side, we just get a 3. And so f of 1 is going to be 3. Let's grab a different one. Let's say I want to do f of 2. And let's do that one in blue. Okay, well, I have 2 as my input, and let's track it. Oh, let's not use blue. I've already used blue for some stuff on the inside. So let's use green. So 2. Okay, so 2 goes into my sorting machine, and we figure out which bin it falls into. Well, if I look at my top 2 bins, then the 2 is on the borderline. And so the question is, which bin actually includes 2? And we can see that the middle one does, because the middle one includes the option of it equaling 2. So this one's also going to go to the middle bin, and it's going to go through the constant function 3, and so this one is also going to give us an output of 3. Let's do one more that maybe goes into a different bin. Let's do f of negative 1. And let's do that one in red. Let's change it up. Let's do purple. That looks different enough. So let's do -1. All right, so our input is going to be -1. We plop that into our sorting machine, and we say, okay, which bin does this fall into? Well, -1 is a negative number, so it's less than 0. So that's going to fall into our third bin. And so it goes into this third machine here. We take x minus 1 for that machine. Our x is -1. And so our output gives us -1 minus 1, which is -2. And so f of -1 is -2. So that's how a piecewise function works. The only thing left to mention is, how do we write this down? Because drawing this picture every time would be pretty cumbersome. Okay, well, we still start with f of x equals, just like we would for any other function. And then to take into account the fact that I have 3 components, I'm going to put this curly brackets here, and there's going to be 3 lines. Now, when we draw the machine, the sorting comes first, and the functions, the actual rules for each of the bins come second. But in mathematics, we actually write it the other way around. So we're going to write the rules first, and then we're going to write the bins after that. So for example, in the first one, the rule is x squared plus 2, and then the rule, the sorting bin that goes into is x is bigger than 2. So we leave a little space there. I like to write an if in between it. So it tells me that if x is bigger than 2, that means I'm in that first bin, and I use the rule x squared plus 2 as my function rule. The next one we have is just the constant function 3, and we're going into that one if 0 is less than x is less than or equal to 2. And then our last rule is x minus 1 if x is less than or equal to 0. So just to reiterate what I said a minute ago, this is our sorting, and then these are the rules that go with each bin. So we've written them a little bit backwards from how you would actually input it, but that's our standard mathematical notation for piecewise functions.